Everyone, can you all see the whiteboard? Can you hear me?
We can hear you.
Okay. Okay, good. 3 is the right answer. Hannah, can you explain?
Okay, so since the denominator is I multiplied the denominators of both fractions together and I got 20. So I did 2/5 of the 20, which is 8. 3/4 of 20 is 15. And I had to we had to find which one the minimum number of people in the room wearing both a hat and a glove, so I had to be part of both of those numbers. So I basically did trial and error, figuring out which numbers. Like for example, I tried it out with one first. Like one person had was wearing a hat and a glove. That didn't work, so I tried then 2. That didn't work, and I tried 3. That did work. I did 8 minus 3, which was 5. 15 minus 3, which is 12. I added 3, 5, and 12 together to get 20.
Okay, good. Yeah, so 3 is correct, and that works. I'll show you another way that you can kind of think about this. And think about, we have one class. Let me just imagine this is the class. And we know that 2/5 of them are wearing gloves. So let's say this is the portion that's wearing gloves. And this is the portion that's wearing hats. Something like this. So now in order to make this the least number of people that are doing both, we want ideally them to first cover all of the people, right, in the room, except and kind of overlap as minimally as possible, right? So something like this, where the only overlaps are the ones that need to overlap, and remaining people are either in one or the other, right? So let's think about that. So what would be the case where there would need to be no overlap? What would be true about the two fractions?
Could you repeat your question, please?
Sure. So we're looking at, this is, let's say, like one of these rectangles inside the whole thing is the people wearing gloves. One is the people wearing hats. So what would be true of the fractions if there wouldn't need to be any overlap at all?
2/5 plus 3/4 should equal 1.
Yes, which is not true, but imagine if it was 2/5 and 3/5. Then there wouldn't need to be overlap, right? I put 2/5 of them wear gloves, the other remaining portion wear hats. So the issue is that they add up to more than one, right? So this is why we need to have an overlap. Let's think about 2/5 plus 3/4. What is the sum?
23 by 20.
Good, 23 by 20. So essentially, because this exceeds 1 by 3 over 20, 3 over 20 of the class is overlapped. At least that much portion is doing both, wearing gloves and wearing hats, right? So if we think about 3 over 20, what is the smallest room such that there's an integer number in both, wearing gloves and wearing hats? So if my room is 20 people, then I would just multiply 3 by 20 by 20 and get 3 is my overlap. And let's think about what that would be. So if I had a room of 20 people, 2/5 of them are wearing gloves. So that's 8 people wearing gloves. Then 20 times 3/4 gives us 15 people wearing hats. And the overlap then, there's 20 people total, 15 wearing hats, 8 wearing gloves. So exactly 3 of them are wearing both. Does this make sense? Any questions? Okay, let's move to the second one. Okay, I see one answer of 704. Are there any other answers? Okay, 704 is close, but I think it's a little higher. Sanvi, why don't you explain how you got 704?
So first I kind of drew a block of cheese, and it's 10 centimeters by 13 by 14.
Okay.
Thus 10 slices are cut from the cheese, and each slice has a width of 1 centimeters. It's cut parallel to one face of the cheese. So I kind of just cut 10 pieces off. So first I cut off a piece from each side of the cuboid thing, the block of cheese, and every time I cut a piece off, it reduced the length, width, or height by 1 centimeter.
Good.
So I went from 10 to 10, 13, and 14 to 8, 11, and 8.
Okay.
And then from there on, I cut off another 4 pieces, and I got to 10 times. Wait a minute.
I think 8, 11, 8 is your final one. That's 704.
8, 11, 8 is my final one. Sorry.
Yeah, good. So this is correct that you want to remove subtract 1 from one of the dimensions when you cut off 1. That's correct. So we can do a little better than 8, 11, 8. So let's think about one by one at a time. Okay, so let's think about, this starts off at 10, 13, and 14. And okay, let's just imagine if we cut, let's say we cut a slice in this way. So let's say this is our cut across the line, for instance, here. So imagine these 2 dimensions stay the same, this one and this one. This dimension will reduce by 1 because that's the slice we cut off. Other way would be, imagine we can cut along this line here. This will cut this dimension by 1. And the other way is if we cut, let's say like something here along this line, then we would cut this dimension by 1. So you can imagine in any of the 3 ways that you can cut it, you can cut one of these dimensions by 1. Okay, let's say I only cut 1 slice. Which way do I want to cut it such that the maximum is remaining?
Nine by 13 by 14.
Okay, let's see that. Okay, so that's one way. So if I cut it in that direction, it's going to be 9 by 13 by 14. What are the other ones that I can do?
Ten by 12 by 14.
10 by 12 by 14, right?
Yeah.
Okay, and what's the third?
9 by 13 by 13.
Careful, we only have to cut one dimension, right? 10 by 13 by 13. Think about when I'm cutting this,
I took the. I moved them.
I'm only removing on one dimension. The other two dimensions remain the same. Okay, good. So these are the three. So which one results in the smallest total volume? What is 10 times 13 times 13?
1690.
Good, 1690. 10 times 12 times 14?
1680.
Good. 9 times 13 times 14?
1638.
Okay. Which is the largest remaining volume?
10 times 13 times 13.
Okay, good. Now let's think about it another way. When we have the largest remaining volume, what is true about the slice of cheese we removed?
It has the smallest volume.
Okay, good. So the slice of cheese we removed, how do I describe its volume?
The 130.
Good. So it's either, so in this case, when I drop the 14 by 1, then it's the product of these two, right? Because you can imagine the slice of cheese is either going to be the size of this space, it's going to be the size of this space, or it's going to be size of this space, right? So the size of the cube can either be 10 times 13, it can be 10 times 14, or it can be 13 times 14. Does that make sense?
Yes.
So I want to pick the one that makes the smallest, right? So I would pick 10 and 13. So which dimension would I drop by 1?
Can you repeat it?
Sure. So I know that if I cut a slice, I can cut it either in a way that the slice that I cut is 10 by 13, it's 10 by 14, or 13 by 14, right? So we know that I picked the 10 by 13 one. So what does that mean about the size, the size after I cut the 10 by 13 one?
If you cut 10 by 13, you reduce the 14.
Good. So in essence, what this means is whenever I have some side lengths, right? Let's say they're X, Y, and Z, I want to cut the sides with the two smallest ones, right? That's going to be my smallest slice that I cut off and leave the biggest remaining cube, which means that the largest dimension is the one that I want to reduce by 1 when I cut the slice. Does that make sense?
Yes.
Okay, so now I reach 10 by 13 by 14. I know if I cut one slice, the largest I can have left is 10 by 13 by 13. Now, what's the next one I want to cut to keep it as large as possible?
You have to cut to 13 again.
Good. So what would be left?
10 by 13 by 12.
Okay. What about the next time?
You would cut the 10 times 12, and you'd
Okay.
have
Good. So what would be left?
10 times 12 times 12.
Good. Now what should I cut?
Ten times 11 times 12.
Good. So I want to again always cut the largest remaining dimension, right? Because if I cut a 10 here, if I cut from this side 10, then I'll get a 12 by 12 slice. Versus if I cut from either the other two dimensions, then I'll get a 10 by 12 slice, right? Which would be smaller. So I'll make this 10 by 12 by 11. What about the next one?
You would cut the 10 times 11, and you'd
Good. And what would be the slide?
10 by 11 by 11.
Good. Okay, how many slices have we cut so far?
6.
Okay, Now, how many more do we need to cut?
4.
Okay. So what else should we cut?
10 times 10 times 11.
Okay.
Ten times 10 times 10.
Okay. Now what?
Okay. 9 times 10 times 10.
Good.
And then 9 times 9 times 10. And then 9 times 9 times 9.
Good. Yep. Okay, let's see. So we've cut 1, 2, 3, 4, 5, 6, 7. Now the last 3 would be 9 times 10 times 10. The next one I want to cut from a 10. 9 times 9 times 10. And finally, I end up at 9 times 9 times 9. Does this make sense? So the trick here, once we know that we're always cutting from the largest dimension, you could think about, okay, so once we start at 10 by 13 by 14, okay, we made it 10 by 13 by 13. So think about every 2 of them that I cut, I'll go up to 12 by 12. Then 2 more, I'll be at 11, 11. Then 2 more, I'll be at 10 by 10 by 10. So now every 3, I'll actually cut all the dimensions to 9 by 9 by 9. You can think about, well, after you cut one slice, then I can make it smaller by using the side that's already 9. And again, I can make it even smaller by using both sides, which are already 9. So you can even imagine with a physical cube, if you're actually cutting it, think about what would make it smallest, but you'll see that it's always, as we kind of computed, the largest side, you have to cut along that side, which gives you a slice that's equal to the size of the product of the 2 smaller ones. So in this case, I think that's the easiest. Once you realize this, it should be fairly easy to then go from 10 by 13 by 14 to see what you have to drop each time to finally get you to a 9 by 9 by 9 cube. So what should the answer be here?
729.
Good. Any questions on this? Okay, let's go on to the last one. Any answers from this one? Okay, let's talk about how we'd approach this. So how do I check if a number is divisible by 8? Does anyone know? Okay, let's make it even simpler. How do I check divisibility by 2? When is a number divisible by 2? Anyone? What should the last digit be?
0, 4, 6, or 8.
Good. Okay. 0, 2, 4, 6, or 8. And in other words, I can just say that the last digit is a multiple of 2, right? So it's either 2 times 0, 2 times 1, 2 times 2, 2 times 4, 2 times 3, 2 times 4. Okay, so now let's go to divisibility by 4. Anyone know what the trick is for that? So it should be the last 2 digits should form a multiple of 4. So give me some large number that's a multiple of 4 and we'll check whether it is or not.
Wait, 8,732.
Okay, good. So according to this rule, is it a multiple of 4?
Yes.
Yep. So we took the last 2 digits, 32. 32 is a multiple of 4. So we expect 8732 to be a multiple of 4. Now, can we confirm this is the case? What is 8732 divided by 4?
2183.
2183.
2183.
3? Yeah. Okay, that's correct. 8720. Yeah, 8732. Good. So this is correct. And let's think about one sec why this is the case. So let's write 8732. So if I just separate the last 2 digits, right? I can write this as 8700 plus 32. Now we know 32 is a multiple of 4 by the divisibility rule. Now is 8700 a multiple of 4?
Yes, it is.
Why?
Because anything, well, 100 is divisible by 4. 100 divided by 4 is 25. So any multiple of 100, anything greater than those first 2 digits will be multiple of 4.
Good, exactly. So this is essentially why this rule works, right? Because I can take this number and I can take the last 2 digits, and the remaining part of it must be ending with 00, right? If I take the last 2 digits separately. Now, if it ends in 00, it's a multiple of 100. But 100 is a multiple of 4. So we know this part is a multiple of 4. So it just comes down to, is the last 2 digits a multiple of 4? If it is, then the whole thing is a multiple of 4. If not, it's not. Okay, now can someone use these 2 things and give me a divisibility rule for 8?
Last 2 digits would be a multiple of 8.
Good. Okay, let's check that. You want to give me a big number that we want to try?
10,324.
Okay. Is 324 a multiple of 8?
Yes.
Careful. Let's check that. So this is 40.5.
No, it's not. Sorry.
So what is there something around this that's a multiple of 8? Let's make it 328. Okay, so is 328 divisible by 8?
Yes.
Yeah, it's 41. And 10,328 will be divisible by 8. And let's try it the same way that we just did. 10,000. Actually, let's just change this to 11,000 just for this is a better example. 11,000 plus 328. The same idea here. Is 11,000 a multiple of 8? So it's the same idea here. We said that 8,700 is a multiple of 4 because it's a multiple of 100, and 100 is a multiple of 4. Similar idea here, 11,000 is a multiple of 1,000, and 1,000 is a multiple of 8. So this whole thing is a multiple of 8. So finally, it just comes down to, is this 328, is the last 3 digits a multiple of 8? If it is, then the whole thing is a multiple of 8. Okay, so now that we have this rule, let's go back to the original question. What is the greatest integer multiple of 8 with all digits being different? Okay, so if I told you the last 3 digits were 960. Now this is a multiple of 8. What would be the greatest integer that has all digits different that ends with 960? So would 4960 work? Okay, so what other, so what I could also make it, let's say 875
Oh. 8,
432.
875,321.
Yes.
54321.
Yes. 8754321 right? This works. This has 10 digits. Good. Yeah. So this is one of them that works. Now we want the greatest integer multiple of 8 that satisfies the same kind of idea. So what should we make it end with such that we can make it even bigger than this? I just picked 960 to start off with. What should we make it to make this even bigger?
Can we add zeros to it?
So if I put another 0 here, then I'll just make it 2 zeros, right? So this is not allowed. So right now I said we'll end with 960, right? But how can I make this larger? If I change this 960 to something else, I might be able to make an even bigger number. What should I change this 960 to? So ideally, I want to use the bigger digits, like a digit like a 9 at the beginning, right? That'll make an even bigger number, right? So what digits do I want to use at the end?
Smaller digits.
Okay, good, smaller digits. So what is a multiple of 8 that's 3 digits long that uses small digits?
Can you ask the question again?
Sure. So I want a 3-digit number that's a multiple of 8 with the smallest digits possible. So ideally, I want to just use 0, 1, and 2. If I have to use a larger digit, I can use maybe a 3, but I want to use ideally only these digits. The advantage of this is that I can use the rest of the digits in the front part. So is there a multiple of 8 that uses only these 3 digits?
$120.
Good. Yep, 120 works. 120 divided by 8 is 15. Okay, so now let's say the last 3 digits is 120. What is the largest number that works? You can have all distinct digits. You can use all the digits from 3 to 9.
987654321.
3, after that, what? Close.
3120.
Yes. And this is the answer. So the largest number that we can make that's a multiple of 8 with all digits being different is 9876543120. This makes sense. So the key trick here was knowing that divisibility by 8, only the last 3 digits matter. So once we know that, we can think about, okay, if I want to make this the largest possible number, I want to use the small digits at the end and then put all the large digits before that. So if I want to use the smaller digits here, what is a multiple of 3 that uses these digits 0, 1, and 2? Thus, I can make it start with 9876543. And then you can compare and see if this is bigger than what the first number we tried, right? 87543211960. This starts with 987, but it's the same number of digits, right? So this is clearly larger. I can't go any larger than this, right? I've used all the digits possible, and I'm using 0, 1, 2 at the end. The only number bigger could be like 210 at the end instead of 120, but that wouldn't be a multiple of 8. Does this make sense?
Yes. Yes, it does.
Okay, good. Okay, then that's it for today's class. We'll see you all in 2 weeks.
Thank you.
Thank you.
Thank you.
Welcome.